pretty wild, isn't it? Every other week, it feels like there's a new AI promising to revolutionize how we search for information. You type in a question, and boom, hopefully you get an answer.
Yeah.
But so often, these feel like these mysterious boxes. You don't really know what's going on inside.
Yeah, these black boxes.
And if you're anything like us, you're probably itching to understand how these things actually, work.
Absolutely. When AI is becoming such a central part of how we find and understand information, it's natural to want to peek behind the curtain.
Right.
These closed-off systems, while powerful, can also feel limiting if you're trying to grasp the underlying mechanisms or even, build something new.
Well, that's exactly the rabbit hole we're diving into today. We've got our hands on a fascinating piece of research. Alzubi et al. 2025 Open Deep Search Democratizing Search with Open Source Reasoning Agents.
Quite a title.
It is. And honestly, the title gives you a pretty good hint of what we're going to be talking about. We're going to unpack this new initiative called Open Deep Search, or ODS.
Okay, so our goal in this deep dive is to really get under the hood of ODS. How does it function? What makes it different from what's already out there? And perhaps most importantly, what does it mean to have an open source approach to AI search compared to the closed systems we're now used to?
Yeah, what are the implications? Hopefully we'll have a few of those aha moments along the way.
Let's hope so.
Okay, let's unpack this. The paper kicks things off by talking about the current big players in AI search. You know the names: Google, Bing, ChatGPT search, Grok.
The usual suspects.
Right. But they specifically call out the ones pushing the envelope with more advanced AI smarts,
right,
like Perplexity AI's Sonar Reasoning Pro and OpenAI's GPT-4o Search Preview.
Right, and these proprietary systems have certainly made impressive progress in weaving AI into the fabric of search. I mean, they can do some pretty amazing things in terms of finding and pulling together information for you.
But, and this is the key point the researchers make, there are some real drawbacks. Because these are essentially secret recipes, we don't really know the ingredients or how they're mixed.
Exactly, no transparency.
We don't have a clear view into how these systems make decisions, what data gets prioritized, or how they might be reflecting certain biases.
And that lack of openness can really stifle new ideas and innovation in the field. If you can't see how something works, it's much harder to build upon it or invent something even better.
Totally. It makes it challenging for new researchers and developers. How do you learn from and improve upon these systems when their inner workings are completely hidden?
Precisely. And this is where the whole open source philosophy offers a potential solution, right? A way to overcome these limitations.
Which leads us directly to Open Deep Search, or ODS. Now, right from the start, the paper presents ODS as an open source AI search framework that's not just trying to be an alternative, but actually aiming to be as good as or even better than these big proprietary systems. That's a pretty ambitious goal.
It is, yeah. But the core idea behind ODS is quite interesting. They're taking the latest open source large language models. Think of these as the AI's core intelligence.
Okay.
And giving them enhanced reasoning capabilities by connecting them with what they call reasoning agents. These agents are the smart guides that know how to effectively use web search tools.
So it's like taking a really smart open source AI and giving it an even smarter assistant who's like an expert at finding and using information on the web.
That's a very helpful way to visualize it. Think of the open reasoning agent as the conductor of an orchestra. It takes your question and figures out the best way to get it answered.
Right.
And a crucial part of that is using their other key innovation, the open search tool.
Okay, so ODS has these two main components working together. Let's dive into the open search tool first. The paper mentions that while there are other open source search tools out there, like OpenPerplex and Perplexity,
I've seen those.
they have limitations?
Yeah.
Apparently, they often just feed a raw list of search results directly to the AI.
And that's a really important distinction. Simply throwing a bunch of search results at an AI can be overwhelming and doesn't necessarily lead to insightful or accurate answers.
Right, it needs more guidance.
Exactly. The open search tool aims for a much more refined and, intelligent process of gathering information.
And it sounds like it's quite a detailed process. The paper outlines a few key steps. First, there's query rephrasing.
Yeah.
This is where the system takes your original question and comes up with several related ways of asking the same thing.
Smart.
They give an example. If you ask how to make my internet faster, The tool might also search for things like how to make the Wi-Fi signal stronger, how to increase bandwidth, and how to reduce latency.
That makes perfect sense. It's like anticipating all the different angles someone might approach the same underlying need. It helps broaden the search and capture any nuances or like hidden context in your original question.
It's about understanding what you really want to know, even if your initial phrasing isn't perfectly precise.
Exactly. Then comes retrieval. And this is where they've taken inspiration from something called fresh prompt.
Okay, fresh prompt. What's that about?
Well, it sounds like they're not just grabbing snippets of text from the search results pages, but also pulling in the important background information.
Like metadata.
Yeah, exactly. Like title of the page, the website address, URL, a short description, and even when the page was published.
So context.
That background information provides crucial context. It helps the system, guided by the AI, make smarter decisions about which sources are likely to be the most trustworthy and relevant.
Makes sense.
For example, the paper mentions that they've specifically instructed the AI to prioritize information from official sources like government websites, educational institutions, and reputable research organizations when there are conflicting pieces of information out there.
So it's trying to be discerning.
It's about sifting through the vastness of the web and highlighting the more reliable voices.
And the final step in the open search tools process is augmentation. This sounds like it's about going deeper than just the initial list of search results. They're actually going into the top-ranked web pages, breaking them down into smaller, more digestible chunks, and then reevaluating those specific pieces of information based on how well they address your original question.
This is really where the deep in open deep search becomes apparent. It's not just a surface-level scan of the web.
Right.
By extracting the most relevant parts of those top pages and then re-ranking them, the system can perform much more detailed reasoning based on a richer and more focused set of information.
Okay, I see.
Think of it like a researcher not just reading the abstracts of a bunch of papers, but actually diving into the key sections of the most promising ones.
Got it. Okay, so that's the open search tool. Pretty sophisticated. Now let's talk about the brain that coordinates all this activity. The open reasoning agent.
Right, the conductor.
The paper stresses that this agent takes your initial question, looks at the information coming from the search tool, and then decides on the best course of action to get you an answer. And they've actually developed two different ways this agent can work.
That's right. The first approach is called ODS V1, and it's built using something called the REACT framework.
REACT.
Yeah, REACT is interesting because it combines the AI's ability to reason step by step with its ability to take actions, like using the search tool.
Okay, chain of thought reasoning. That's where the AI essentially shows its work, explaining its thought process step by step.
Exactly. It's like seeing the AI's internal monologue.
Yeah.
And REACT adds the action part, which allows the model to interact with the outside world through tools.
Oh,
it's a cycle. The agent thinks about the problem, takes an action, like performing a search, sees the results, observes, and then continues to think and act until it finds an answer. Figure 2 in the paper gives a good visual of how this thought-action-observation loop works.
And to make this even smarter, ODS V1 uses dynamic few-shot learning, which sounds fancy.
It does, but the idea is pretty intuitive. Instead of just giving the agent a fixed set of example questions and answers to learn from, it selects a small number of the most relevant examples to help it reason through each new question.
That's a great way to put it. It's like having a tutor who doesn't just give you the same practice problems every time, but instead picks the ones that are most similar to the exact question you're currently trying to solve.
Exactly. This makes the learning process much more efficient and tailored to the specific challenge.
Cool.
And the paper mentions a really fascinating way they gathered these examples. They actually got the community involved in designing 200 of these example prompts.
No way. How did that work?
Well, they gave people the basic structure of how REACT works and some sample questions. But crucially, they didn't give away the actual test questions.
Ah, clever. So it's like crowdsourcing different problem-solving strategies. That variety of thinking styles in the examples must have really helped the agent become more adaptable.
The research certainly suggests that. And ODS V1 isn't just limited to web searching. It can also use other tools.
Like what?
Like the Wolfram Alpha API for doing math.
Oh, useful.
And even a continue thinking tool that allows the underlying AI to further break down really complex questions.
So it can pause and think deeper if needed.
Pretty much. They've even built in a backup plan. If the REACT agent kind of gets stuck or can't come up with a solid answer, It falls back to using chain of thought self-consistency.
Okay, what's that?
Basically, it generates multiple different reasoning paths and then picks the answer that seems most consistent across all of them, a sort of safety net.
That sounds like a really robust and well-thought-out system. Now, what about the second version, ODS v2? This one is based on CODACT. How does that differ from the REACT approach?
Okay, so CODACT builds on the idea of chain of code. While chain of thought is excellent for reasoning about language and concepts, it can sometimes struggle with precise calculations or tasks that require very specific interactions with tools.
Right, like numerical stuff.
Exactly. Chain of code leverages the AI's ability to write and even execute small pieces of code or something very similar to code to handle these kinds of tasks more accurately.
So instead of just thinking in natural language steps, it can actually write and run little snippets of code to help it with the reasoning process. That's clever.
It is. And CODACT takes this a step further by generating actual executable Python code for interacting with tools.
Real code.
Real Python code. The researchers argue that this is a more direct, efficient, and flexible way to use tools compared to more traditional methods, like formatting things in JSON.
I can see that. Less translation needed.
Precisely. They've even integrated ODS v2 with a framework called Small Agents, which is designed for building and managing customizable AI agents. Figure 4 in the paper illustrates how CODACT works when tackling a question that requires multiple steps of reasoning, showing the AI generating and executing code to arrive at the final answer.
Okay, so we have these two different ways for the open reasoning agent to operate, V1 with REACT and V2 with CODACT, both relying on that powerful open search tool.
Correct.
Now, for the really interesting part, how well does ODS actually perform when put up against the competition? The paper presents some results from standard AI benchmarks.
Yes, Table 1 in the paper shows a comparison on two important benchmarks, SimpleQA and FRAMES.
Right.
They tested ODS specifically using a powerful open source AI called DeepSeek R1 as the base model.
Okay, DeepSeek.
Against some of the leading closed source AI search systems, including GPT-4o Search Preview, Perplexity, and Perplexity Sonar Reasoning Pro.
And what were the main takeaways from those comparisons? It looked like ODS v2, the CODACT one with DeepSeek R1, showed a pretty significant improvement on the FRAMES benchmark compared to GPT-4o Search Preview.
That's a key finding, yeah. ODS v2 achieved a 75.3% accuracy rate on FRAMES, which was noticeably higher than GPT-4o Search Preview's 65.6%.
Wow, that's quite a jump.
It is, and importantly, both versions of ODS v1 and v2 outperformed Perplexity AI's top-tier products on both of these benchmarks.
So outperforming the commercial competition in these specific tests.
In these tests, yeah.
For anyone who might not be familiar with these tests, can you briefly explain what the SimpleQA and FRAMES benchmarks are designed to measure?
Certainly. SimpleQA, as the name suggests, is designed to test how well an AI can answer straightforward, factual questions. But the questions are often designed to be a bit tricky or adversarial.
Okay, short, factual, maybe a bit tricky.
Right. FRAMES, on the other hand, stands for Factuality, Retrieval, and Reasoning Measurement Set. It focuses on questions that require the AI to pull together information from multiple different sources, often Wikipedia.
Multi-hop reasoning.
Exactly. And perform more complex reasoning to arrive at the answer. It really tests that deeper understanding and synthesis capability.
Table 2 in the paper also caught my eye. It showed the average number of web searches that ODS v1 and ODS v2 used when tackling these different benchmarks.
Ah, yes, the efficiency aspect.
It seems like ODS is adapting how many searches it performs, depending on how complicated the question is. It's not just doing, say, 3 searches every time.
Exactly right. Unlike some systems that might perform a fixed number of searches no matter what you ask, ODS's reasoning agent can intelligently decide when it needs to search again.
How does it decide?
Based on how good the initial search results look and how confident the AI is in its current understanding. Table 2 shows, for instance, that ODS v2 used significantly more searches when dealing with the more complex FRAMES questions compared to the simpler SimpleQA questions.
That makes sense.
And it's interesting to note that when ODS v1 was using a slightly less powerful base AI like Llama 3.170B, it tended to perform more web searches, perhaps to compensate.
So it adapts based on the underlying model's capability too.
Seems like it.
The paper also includes some specific examples that really highlight where ODS shines. For example, there's the FRAMES question about who won the Lenore Marshall Poetry Prize.
Ah, yes, that was a good one.
Both ODS and Perplexity initially struggled, right?
Yeah.
But ODS v1 managed to correctly identify the winner, calculate their age using Wolfram Alpha,
that tool integration again.
And give the right answer of 90 years. Perplexity, on the other hand, went down the wrong path and reported 79 years.
That really shows the power of being able to integrate these external tools for specific tasks like calculation.
Definitely. And there are other compelling examples in Section 2.2.1 and especially in Appendix A. What about the Jensen interceptor wheelbase question?
Right, the frames question about the wheelbase. ODS v1 was able to reconcile conflicting information it found on different websites.
Which happens all the time online.
Absolutely. And it even used Wolfram Alpha again to convert the answer into millimeters, giving a precise result. Perplexity Pro apparently got confused by the different measurements it found.
Okay. Another win for integrating tools and reasoning. What about SimpleQA examples?
Yeah, there was a SimpleQA question about track 10 on a specific soundtrack. ODS v1 with DeepSeek R1 was able to leverage really high-quality information it found online, good context retrieval, to give the correct answer, break in.
And Perplexity?
Perplexity, Sonar Reasoning Pro, according to the paper, seemed to have trouble even finding the track listing.
So the quality of the retrieved info from the OpenSearch tool matters a lot.
It seems critical. These examples really underscore the combined strengths. The OpenSearch tool finding relevant, high-quality info, and the Open Reasoning agent analyzing and understanding that information effectively.
Sometimes even outperforming the best closed-source systems, as you said.
In these specific examples, yes. The paper provides several more of these detailed comparisons in the appendix, like cases where ODS performed follow-up searches when the first try wasn't enough.
Like the Kanye West sample question.
Exactly, or the Levi Strauss brand question. It shows ODS resolving ambiguities, using tools for calculation like figuring out time elapsed or converting units, and arriving at accurate answers where proprietary systems sometimes stumbled.
There were quite a few examples in that appendix showing nuanced reasoning, like the Frappuccino founding date difference or identifying Hayao Miyazaki based on clues.
Right, or resolving conflicting dates for Caitlin Armstrong's plea, or finding Rosie Perez's other job on In Living Color by cross-checking. It points towards a more robust reasoning process.
They even conducted what's called an ablation study, right? Where they essentially tested how much each individual component of ODS v1 contributed to its overall performance.
Yes, Table 4 showed that.
And it seemed like the OpenSearch tool, the React agent itself, and those carefully chosen community examples they used for learning all played a really important role in achieving those results.
That's right. It highlights that it's not just one magic bullet. It's the combination of these different elements, the quality of the information retrieval, the reasoning process itself, and the effective learning methods that leads to ODS's strong performance.
Okay, that makes a lot of sense. So we've looked at how ODS works and how it performs in these tests. Now let's circle back to why it's significant that it's open source. The paper really emphasizes the advantages of this approach.
Definitely. The core benefit of being open source in this context is the potential for broad community involvement. It's huge.
How so?
By making the ODS code publicly available on GitHub, the researchers are basically inviting developers and researchers from all over the world to contribute their ideas, build upon the existing work, and drive further innovation.
So harnessing collective intelligence.
Exactly. This collaborative approach has the potential to accelerate progress much faster than if development just happens behind closed doors in a few companies.
And that transparency is crucial, isn't it?
Yeah.
We talked earlier about these proprietary systems being like black boxes.
Right.
With ODS being open, researchers can actually examine how it works, identify any potential biases or limitations, and work together to make it even better.
It's almost like moving from a restaurant with a closed kitchen to one where you can actually see how your food is being prepared.
Yeah, that's a good analogy. It definitely builds more trust.
Absolutely. This transparency also helps build trust among users. They can have a better understanding of how their search queries are being handled and what sources of information are being used to generate answers.
Less mystery.
Less mystery.
Yeah.
And the paper also briefly touches on some of the wider potential risks associated with closed-source AI search engines, things like bias, hallucination, potential for surveillance, maybe even spreading dangerous info.
Which are valid concerns.
Very valid. An open-source alternative offers a way to address these concerns through public scrutiny and collaborative improvement. It's not a magic fix, but it's a different approach.
So to sum up our deep dive then, Open Deep Search appears to be a really significant step forward. It's about making advanced AI search capabilities more accessible, more transparent.
Yeah, providing a powerful and transparent alternative to the closed-source systems that currently dominate how we find information online.
And it's shown it can compete.
Indeed. ODS, with its innovative open search tool and intelligent open reasoning agents, has shown that it can not only compete with, but in some cases, on these benchmarks at least, even outperform state-of-the-art proprietary solutions.
And the fact that it's open source holds tremendous potential for future advancements and community-driven innovation in this vital area.
Absolutely.
It really makes you think about the bigger picture, doesn't it? Like, what are the wider implications for how we'll access and understand information in the future when we have powerful, transparent, and open source AI tools like ODS becoming available?
That's a great question.
It's exciting to consider the potential for further innovation and the role that a collaborative community can play in shaping the future of search. Where does this lead?
Well, it raises a fundamental question, I think, about the balance between innovation driven by individual companies and the collective power of open collaboration. As AI continues to transform how we interact with information,
Which it clearly is.
the principles of transparency and community involvement, as seen in projects like ODS, could be really essential for ensuring a more equitable and trustworthy information landscape for everyone. It's something to watch for sure.